So what about unpaired electrons? It's our starting point when trying to write ionic and covalent formulae. Let's look at the formation of sodium chloride again for just a quick recap. So as a reminder, NaCl, the sodium atom and the chlorine atom, and here are the unpaired electrons. Sodium has an electron configuration of 281 in numbers, and chlorine atoms 287. The sodium atom loses an electron and turns into a sodium ion. Its electron configuration changes from 281 to 28, and chlorine accepts this electron and changes into a chloride ion, and its electron configuration changes from 287 to 288. The two oppositely charged ions are now attracting each other. It's electrostatic attraction that we call an ionic bond. Their electron configurations have changed, and you can see that. The sodium ion is a cation and the chloride ion is an anion. Let's tackle a few more of these while thinking about unpaired electrons. So magnesium and fluorine are reacting. Magnesium has an electron configuration of 282 that you can get from the atomic number from the periodic table. Watch the other video if you're not sure, but you can see this from the picture. And fluorine's electron configuration is 27. The magnesium atom has 2 unpaired electrons and the fluorine with 1 unpaired electron. This tells us that the magnesium will form 2 ionic bonds, while the fluorines will form 1 ionic bond each. We use this symbol here to show an electron. The magnesium atom gives up its unpaired electrons to 2 fluorine atoms, and the configuration and numbers are here. The oppositely charged ions are attracted to each other, and an ionic bond is formed again. And the configuration and numbers, the oppositely charged ions are attracted to each other and an ionic bond is formed again. So the magnesium atom becomes a positively charged ion or cation, and the fluorine atoms become negatively charged ions or anions. We can go a step further here. Forget about pictures and write a word equation, followed by a symbol equation. From a previous video, you can see that fluorine is diatomic and written as F2. We can even go one step further than this and show what is happening with the electrons again in an equation like this. So Mg atoms changing into Mg2 plus ions and are releasing 2 electrons. And then the fluorine atoms are accepting these electrons and changing into F1 minus ions. But of course it is F2 because fluorine exists as diatomic molecules. These are ion-electron half equations, and more on this in a separate video. Another example of ionic bond formation, and we'll make it a bit trickier this time. How about aluminium reacting with oxygen? So the aluminium gives away its outer 3 electrons to become an aluminium ion. Well, obvious, aluminium loses 3 electrons, so its electron configuration changes from 283 to 28, and the oxygen atom changes into O2 minus ions because the oxygen atoms have accepted these electrons from aluminium. So how many oxygens, or should I say how many oxide ions, will combine with 1 aluminium ion? Look at the pictures of both these ions, aluminium 3+ and oxygen 2-. To work it out, remember the charges have got to balance and give no overall charge. Not so obvious, I know. This would mean 1.5 oxide ions for each aluminium, but that doesn't work. 3+ ion, and of course this is not possible as we can only have whole atoms or ions. But if we show the pictures of the atoms again, it helps us to work out the ratio of the ions like this. The number of unpaired electrons have got to match or balance. To make the unpaired electrons balance, we multiply aluminium by 2, and the oxide ion we multiply by 3, and we get this formula. Try these ones for yourself. The answers are on the next video. All for now.